Welcome to Gelmar Tech Lab, where imagination becomes innovation. Build, code, innovate. Every dream begins with a spark, lighting up the future through the dark. Every circuit, every...
Welcome to Gelmar Tech Lab, your destination for electronics, embedded systems, IoT, and engineering projects. This is the ESP32 Master Course, where we'll take you from beginner to advanced through practical, hands-on lessons. In Episode 1, you'll learn what the ESP32 is, why it has become one of the world's most popular microcontrollers, and how it is used in real-world applications such as IoT, home automation, robotics, industrial control, and smart monitoring systems. By the end of this lesson, you'll have a solid understanding of the ESP32 and be ready to begin your embedded systems journey. Welcome to Gelmar Tech Lab. Welcome to the ESP32 Master Course, where you'll learn the fundamentals of ESP32 programming, electronics, embedded systems, Internet of Things, automation, and real-world engineering projects. Whether you're a beginner, student, technician, electrical practitioner, or engineer, this course is designed to guide you step by step, from the basics to advanced applications through clear explanations, practical demonstrations, and hands-on projects. Let's begin our journey into the world of ESP32 and embedded systems. Now, let me introduce myself. My name is Gelmar Ramillano, and I'll be your instructor throughout this ESP32 Master Course. I hold a bachelor's degree in electrical engineering and work as an electrical practitioner with experience in electronics, industrial automation, embedded systems, and real-world engineering applications. My passion is sharing practical engineering knowledge and helping others develop the skills needed to design, build, and troubleshoot modern electronic systems. Throughout this course, I'll guide you step by step using clear explanations, hands-on demonstrations, and real project examples. Our learning journey will cover ESP32 development, embedded systems, Internet of Things, electronics, industrial automation, PCB design using KiCad, Arduino programming, and practical engineering projects. Together, we'll turn engineering ideas into real-world solutions. Let's begin our ESP32 Master Course. Before we begin, let's take a quick look at what you'll learn in this first episode of the ESP32 Master Course. This course is designed to help you master the ESP32, from the fundamentals to advanced applications through practical step-by-step lessons. You don't need any prior programming or electronics experience. We'll learn together using clear explanations, hands-on demonstrations, and real engineering examples. This course is perfect for beginners, students, hobbyists, electrical practitioners, technicians, and engineers who want to develop practical skills in embedded systems and Internet of Things technologies. In Episode 1, we'll answer the question, what is the ESP32? We'll explore its key features, discover its real-world applications, compare it with Arduino, and finish with a course roadmap so you'll know exactly what to expect throughout this master course. Let's get started and begin our journey into the world of ESP32 and embedded systems. Now, let's answer one of the most important questions in this course. What is the ESP32? The ESP32 is a powerful 32-bit microcontroller developed by Espressif Systems. It is one of the most popular development platforms for embedded systems and Internet of Things, or IoT applications, because it combines high-performance, wireless connectivity, and a wide range of built-in peripherals in a single, affordable chip. One of its key features is its dual-core processor, which can run at speeds of up to 240 MHz, allowing it to handle multiple tasks efficiently. It also includes built-in Wi-Fi and Bluetooth, making it ideal for wireless communication without requiring additional modules. The ESP32 provides up to 34 general-purpose input and output, or GPIO pins, which allow you to connect sensors, displays, relays, motors, and many other electronic devices. It also supports analog to digital conversion, digital to analog conversion, and pulse width modulation, enabling accurate sensor readings, analog signal generation, and motor control. Another major advantage of the ESP32 is its low-power operation, making it suitable for battery-powered and energy-efficient applications. Because of these powerful features, the ESP32 is widely used in smart home systems, robotics, industrial automation, Internet of Things devices, and energy monitoring applications. Throughout this course, you'll learn how to use these capabilities to build practical, real-world engineering projects step by step. Now, let's answer one of the most important questions in this course. What is the ESP32? The ESP32 is a powerful 32-bit microcontroller developed by Espressif Systems. It is one of the most popular development platforms for embedded systems and Internet of Things, or IoT applications, because it combines high-performance, wireless connectivity, and a wide range of built-in peripherals in a single, affordable chip. One of its key features is its dual-core processor, which can run at speeds of up to 240 MHz, allowing it to handle multiple tasks efficiently. It also includes built-in Wi-Fi and Bluetooth, making it ideal for wireless communication without requiring additional modules. The ESP32 provides up to 34 general-purpose input and output, or GPIO pins, which allow you to connect sensors, displays, relays, motors, and many other electronic devices. It also supports analog to digital conversion, digital to analog conversion, and pulse width modulation, enabling accurate sensor readings, analog signal generation, and motor control. Another major advantage of the ESP32 is its low-power operation, making it suitable for battery-powered and energy-efficient applications. Because of these powerful features, the ESP32 is widely used in smart home systems, robotics, industrial automation, Internet of Things devices, and energy monitoring applications. Throughout this course, you'll learn how to use these capabilities to build practical, real-world engineering projects step by step. Now, let's compare the ESP32 with one of the most popular development boards for beginners, the Arduino Uno. Understanding the differences between these two platforms will help you choose the right board for your projects. Let's start with the processor. The ESP32 features a powerful dual-core processor running at up to 240 MHz, while the Arduino Uno uses a single-core 16 MHz microcontroller. This gives the ESP32 significantly more processing power for complex applications. When it comes to connectivity, the ESP32 has built-in Wi-Fi and Bluetooth, allowing it to connect directly to wireless networks and smart devices. In contrast, the Arduino Uno requires additional external modules for Wi-Fi and does not include built-in Bluetooth. The ESP32 also offers up to 34 general-purpose input and output pins, giving you greater flexibility when connecting sensors, displays, relays, motors, and other peripherals. The Arduino Uno provides 14 digital input and output pins, which are sufficient for many basic projects, but offer fewer expansion options. For analog input, the ESP32 includes a 12-bit analog-to-digital converter, providing higher measurement resolution than the Arduino Uno's 10-bit ADC. It also has 520 kilobytes of RAM, compared to just 2 kilobytes on the Arduino Uno, making it much better suited for multitasking and memory-intensive applications. So, which board should you choose? If you're completely new to electronics and programming, The Arduino Uno is an excellent platform for learning the fundamentals. However, if you plan to build Internet of Things devices, automation systems, wireless applications, or projects that require greater performance, the ESP32 is the better long-term choice. In this course, we'll focus on the ESP32 because of its powerful features, wireless capabilities, and versatility for modern engineering projects. Now that we've explored the features of the ESP32, let's look at how it is used in real-world applications. The ESP32 has become one of the most popular microcontrollers because it combines powerful processing capabilities with built-in Wi-Fi and Bluetooth. This makes it an excellent platform for developing smart, connected devices across many industries. In smart homes, the ESP32 is used to control lighting systems, smart switches, door locks, security cameras, and home automation devices that can be monitored and controlled remotely. In industrial automation, it is used for machine monitoring, process control, remote data acquisition, and predictive maintenance, helping improve efficiency and reduce downtime. The ESP32 is also widely used in robotics, where it controls motors, reads sensors, communicates wirelessly, and enables autonomous operation. For Internet of Things, or IoT applications, the ESP32 collects data from sensors and sends it to cloud platforms for real-time monitoring and analysis. This makes it ideal for environmental monitoring, smart buildings, and connected devices. Other popular applications include energy monitoring systems, smart agriculture for automated irrigation and crop monitoring, weather stations that measure environmental conditions, and smart security systems such as motion detectors, access control, and surveillance devices. As you can see, the ESP32 powers thousands of modern embedded systems around the world. Throughout this course, you'll learn how to design and build many of these real-world applications using the ESP32. After learning about the ESP32's features and real-world applications, you might be wondering, why should you choose the ESP32 over other microcontrollers? The answer is simple. The ESP32 offers an excellent combination of performance, connectivity, affordability, and flexibility, making it one of the most powerful and cost-effective microcontrollers available today. First, the ESP32 is highly affordable, while offering professional-grade features that are typically found in more expensive development platforms. This makes it an excellent choice for students, hobbyists, engineers, and product developers alike. Its powerful dual-core processor, running at speeds of up to 240 MHz, provides the performance needed for multitasking, real-time processing, and complex embedded applications. Unlike many traditional microcontrollers, the ESP32 comes with built-in Wi-Fi and Bluetooth, allowing you to create wireless and Internet of Things applications without adding extra communication modules. Another important advantage is its low power consumption. The ESP32 includes advanced power-saving features, such as deep sleep mode, making it ideal for battery-powered and energy-efficient devices. The ESP32 also benefits from a rich development ecosystem. It is supported by the Arduino IDE, Platform I/O, and Espressif's official ESP-IDF framework, giving developers flexibility regardless of their experience level. In addition, the ESP32 has a large and active global community. Thousands of developers continuously share tutorials, open-source libraries, sample projects, and technical support, making it easier to learn and solve development challenges. Finally, Espressif provides extensive official documentation, detailed technical references, and software development resources that help both beginners and professionals build reliable applications with confidence. For all of these reasons, the ESP32 has become one of the world's most popular platforms for embedded systems, Internet of Things, automation, robotics, and smart engineering projects. Throughout this course, you'll learn how to take full advantage of these capabilities by building practical, real-world projects step by step. Now, let's take a look at our learning roadmap and see what you can expect throughout this ESP32 Master Course. This course is carefully structured to guide you from the fundamentals to advanced ESP32 development. By the end of this journey, you'll have the knowledge and confidence to design, program, and build complete ESP32-based embedded systems. In Module 1, covering episodes 1 through 3, we'll build a strong foundation by learning the fundamentals of the ESP32, exploring its hardware architecture, and setting up the Arduino IDE development environment. In Module 2, from episodes 4 to 6, we'll focus on practical programming with GPIO, interfacing different sensors, and working with various display modules to create interactive embedded applications. In Module 3, covering episodes 7 through 10, we'll explore wireless communication using Wi-Fi and Bluetooth, and begin developing real Internet of Things, or IoT projects that communicate with cloud platforms and smart devices. Finally, in Module 4, from episodes 11 through 15, we'll bring everything together by building advanced engineering projects, learning PCB design techniques, and implementing industrial automation solutions using the ESP32. Our final goal is simple: to help you build professional ESP32-based embedded systems with confidence and apply your knowledge to real-world engineering projects. So, let's begin this exciting learning journey together and start building the future with the ESP32. Before we begin our hands-on lessons, let's take a look at the hardware you'll need for this course. Don't worry, you don't need expensive equipment. We'll be using affordable and easy-to-find components throughout our practical projects. The most important item is an ESP32 development board. I recommend using either the ESP32 DevKit V1 or the ESP32-S3 development board, as these boards will be used in our demonstrations and project implementations. You'll also need a USB data cable, either a USB Type-C or micro USB cable, depending on your ESP32 board. This cable will be used to upload programs and communicate with your computer. For circuit prototyping, you'll need a breadboard and a set of jumper wires. These will allow you to build and modify circuits without soldering, making it easy to experiment and learn. Finally, prepare a few basic electronic components, such as LEDs, resistors, and push buttons. As we progress through the course, we'll also introduce additional sensors, displays, relays, and communication modules for more advanced projects. With these basic tools ready, you'll have everything you need to follow along with the lessons and build practical ESP32 projects from the ground up. Let's get started. Learning theory is important, but real learning happens when you build actual projects. That's why this course focuses on practical, hands-on experience using the ESP32. Throughout this master course, you'll design, build, test, and deploy real engineering projects that strengthen your skills in electronics, embedded systems, IoT, and industrial automation. Our first major project is the Smart Overcurrent Protection System. In this project, you'll learn how to monitor electrical current in real time using current sensors, display the measured values on an OLED screen, and automatically disconnect overloaded circuits using relay modules. We'll also integrate a buzzer alarm to provide immediate warning whenever an overcurrent condition is detected. Our second project is the Smart LPG Gas Monitoring System. You'll build an intelligent safety system using an ESP32, an MQ6 gas sensor, a load cell, an OLED display, and the Blink IoT platform. The system will continuously monitor gas levels and cylinder weight, activate alarms when necessary, and send notifications directly to your mobile device. By completing these projects, you'll gain practical experience that you can apply to your own engineering ideas, academic research, industrial applications, and professional IoT solutions. Let's begin building real-world ESP32 projects together.
Welcome to Gelmar Tech Lab, where imagination becomes innovation. Build, code, innovate. Every dream begins with
Congratulations! You've successfully completed Episode 1 of the ESP32 Master Course. In this lesson, you've learned what the ESP32 is, why it's one of the most powerful microcontrollers available today, and the key features that make it an excellent choice for embedded systems, IoT, and automation projects. We also compared the ESP32 with the Arduino Uno, explored its real-world applications, and discussed the essential hardware you'll need to start building your own projects. You're now equipped with the foundational knowledge needed to begin your ESP32 journey with confidence. This is just the beginning. There's so much more to explore and create. In the next episode, we'll install the Arduino IDE, configure the ESP32 development environment, and upload your very first ESP32 program. We'll take everything step by step, so even if you're a complete beginner, you'll be able to follow along with ease. Thank you for watching. If you found this lesson helpful, don't forget to like the video, subscribe to Gelmar Tech Lab, and turn on the notification bell so you won't miss the upcoming episodes. I'll see you in Episode 2. Happy learning and happy building. Now that you've learned the fundamentals of the ESP32, it's time to move from theory to hands-on programming. In Episode 2, we'll set up the complete ESP32 development environment from scratch. I'll guide you through every step, making the process simple and easy to follow, even if you've never programmed a microcontroller before. Together, we'll install the Arduino IDE, add the ESP32 board package, configure the development environment, and connect your ESP32 board to your computer using a USB cable. Once everything is set up, you'll upload your very first ESP32 program, the classic Blink LED project. Along the way, you'll learn how to use the serial monitor for debugging, understand the upload process, and troubleshoot common issues that beginners often encounter. By the end of Episode 2, your ESP32 will be fully configured and ready for the exciting projects we'll build throughout this master course. So, make sure you don't miss the next lesson. Subscribe to Gelmar Tech Lab, turn on the notification bell, and join me in Episode 2 as we begin programming the ESP32 together. Thank you for watching. and I'll see you in the next episode. Congratulations once again on completing Episode 1 of the ESP32 Master Course. I hope this lesson has given you a strong foundation and inspired you to begin your journey into embedded systems and IoT development. If you enjoyed this lesson and found it helpful, please give this video a thumbs up. It really helps the channel grow and allows me to create more high-quality engineering content for you. I'd also love to hear your thoughts, so leave a comment below with your questions, feedback, or the projects you'd like to build using the ESP32. Don't forget to subscribe to Gelmar Tech Lab and turn on the notification bell so you'll never miss the next episode of this master course. And if you know someone who wants to learn ESP32, electronics, embedded systems, IoT, or automation, please share this video with them. Together, let's build a community of engineers, makers, and innovators. Thank you so much for watching. I'm Gelmar Ramilano, and this is Gelmar Tech Lab. I'll see you in Episode 2. Until then, keep learning, keep building, and keep innovating. Goodbye, and see you in the next lesson.